It's an honor to be here. There are so many new faces, and I'm really excited about that because you'll see from what I'm going to share with you, that's what we need, the opportunity to meet, connect, feel that others are working with us and that we're together in this effort. I hope to say some things that will inspire. I hope to say some things that will provoke personal reflection. And I hope to say some things that will promote an opportunity to connect with me and or to connect with one another in new ways. The responsibility I was given is to speak and share ideas about where we sit in this Bullseye framework globally. So you'll see some global science on the mountains, and to provide hope. That's it, right? Global and hope. Let's see if we can do that. Snow is changing here. It's changing everywhere in the world's mountains. Its presence and persistence is declining. That's not unique to our region. You heard from the video and from these two folks who spoke, it's a hotter planet. What does it look like on a hotter planet? The mountains will have a higher snow line. That is changing everywhere in the world. What we don't know well is which mountains will no longer have snow. And that will change, and with tremendous spiritual and cultural impacts when people who are connected to seeing white on their mountains don't see white on the mountains anymore. The mountains in summer may have hardly any snow, and that's what this picture is. This picture is our mountains. This is 2020. Up in the upper Animas River Valley, and it's different than Colorado when I moved here 30 years ago. You could always get a good glissade in somewhere, and y'all know there's a bunch of recreationalists who want to ski every month, and skiing in July and August is getting a little bit harder than it used to be September as well. On a hotter planet, snow doesn't stick around as long without a March and April resupply. So when we're looking at snowpack, we get excited when we get that first snow. We may see that we're at 100% in January and February, but as Becky spoke, it just goes faster. And that resupply of snow this time of year is ever more critical, especially because we get those dust events, and the dust covers the surface of the snow. It increases the radiation absorption. The melt happens faster. And if we have new white snow, we all know we get some snow events with dust. It's those clean snow events that make a difference in spring. How does it feel when we recognize that this is what our mountain world around us looks like? It's important to get in touch with our feelings about things. And then it's important to recognize that that's hard, but to know that we're not alone in this work. So, key message, we're not alone in this work. There we go. So the title of this session is The Bullseye, Finding the Bullseye, Thinking about the Bullseye. We're in one of the bullseyes on our planet, in particular for water. In many regions of the world, there are people and species who are highly dependent on snow. The blue areas on this global map with a red outline around them are all parts of the world where there is it's a map of accumulated annual snowfall divided by annual runoff. So how much of the water that's being supplied in a region comes from the snowpack? It's a lot of our planet. It's a lot of our northern hemisphere. It's regions that do have mountains, and it's regions that don't have mountains. The little inset graph on the lower left, those red areas are the mountainy parts. So if you kind of can visually put those two maps together, you can get a sense for, there's a bunch of the Arctic that's not super mountainy, but has a really important, snow has a really important role. In other regions of the world that aren't highlighted in the blue, they are regions where rain is more critical than snow, and or where there's glaciers. The glaciers are an even bigger bullseye on our planet right now than the regions with snow, because it takes more to get a glacier back. It takes more time to get a glacier back when a glacier has lost mass than it does to get snow back as we want to think about what can our actions be to sustain our snow systems on the planet. Y'all know this, right? Mountain snow is magic, and I hope it's okay for a scientist to talk about magic. That's one of the things that I want to do to provoke some reflection is I'm often told when I speak with journalists, they'll say, "You don't sound like a scientist." I'm like, okay, I am. I trained. I got the PhD. I spent 30 years doing this, almost entirely in Colorado. I made that choice because Colorado, I didn't think it made sense to live in another state and study mountains. I mean, there are some other states that have mountains, but this is a state that I picked. My PhD's from Boulder. And so yeah, let's talk about the magic. You know what I'm talking about. You know that when that water comes as snow, it moves into the ground. And from infiltrating into the ground, it can move into groundwater, and we can sustain our water systems for a longer period of time without us having to do anything because that water moved to depth rather than that it's part of runoff or it's part of the managed water system of reservoirs. The same amount of water coming as rain doesn't do that. And there's a whole lot of physics behind all of that, but we can talk about it as magic, I hope. It's important to note that globally, and in our region, it's oftentimes that deserts are nearby. We get mountains and deserts together. It's because of where and how we end up with that rain shadow effect. And so we are interconnected to the desert regions surrounding our mountain region. We know that because we know those are the folks that depend on the water and the water compacts that Rob was talking about. We also know that because we're connected by the air and the air systems, and dry places are desertifying through the changing climate systems, through some of our land use choices, and we see more of we can see that in the dust that comes into our region. First, when I do work with Center for Snow and Avalanche Studies, and I've done dust on snow experiments, but it's truly remarkable when you first start to spend more time in the Southwest. I moved here 13 years ago from the Front Range, just how much dust can come in. And I think one of my first big surprises when it was raining mud. Y'all have seen that, right? And I mean, you can tell people what it's like when it rains mud, but it's a different thing to live through raining mud. So if our earth is connected, land and land is connected, water and air is connected, people have to be connected. We cannot do this work alone. We are not alone in doing this work. So what are the kind of choices we make to make sure we're connected with people? I'm going to take a swing at this one. These two talked about variability in the system. Yeah, we live in a place with huge interannual variation, and it makes it tough to tell stories about how the system's going to change over time, as particular with precipitation. As Becky highlighted, each of these years is an opportunity to learn. An opportunity to learn because this graph has snowmelt date on the x-axis, and then it has thaw degree days, 14 days after snow free. So it's like growing degree days. You just add up the temperature for every day after snowmelt. And those two things are what tell the system it's time to go. It's go time when there's less snow and not snow cover, and if it's warmer. And the plants respond, the animals respond. The changing energy dynamics in the system mean that the snow melts even faster. So we want to pay attention to both when the snow is gone and how hot it is after the snow is gone. And then what I keep trying to think about is how do we coordinate better, cooperate more in the moment planning and in the moment learning of what we can do in each of these extreme climate years, because we will get some years with lots of snow. And we want to learn a lot in those years with lots of snow, knowing that there's also the years, the more frequent years with less snow. I hope to have some conversations today with folks about opportunities to learn and what we can do in relation to this. Look at that modeling hope. I was told to bring hope in. That's what hope looks like. We had one model run in 2018 that went out there and said, yeah, we could still get a lot of snow. But what I remember more is the conversations I had in 2018 and talking to folks around town, and they're like, oh yeah, we get snow in March. It snows a lot in March. And then people were like, oh, don't worry, it'll snow in April. And then April went by. Yeah, I'll remember that snow year, right? We didn't get a lot. we got a big fire instead. And I still remember talking to people in April, and they're like, don't worry, sometimes it snows a lot in May. We are a hopeful species. That is part of what we do. And it's okay to model hope, and it's okay to dream and to vision what we want, but we also have to think about what we want, why we want it, and then act in consistent ways to have it not all just be hope. We can hope for something and also work towards what we want. So we are not alone in this work. We need to build more inclusive spaces and ways to understand ways of knowing, ways of being from people who know how this region works over the long haul, and folks who understand best the long haul approach from region to region. And I'll highlight that by telling you a story about drained lakes in Alaska and a woman who was amazing, and how no one saw or listened to her. So I work at an indigenous serving institution, and I was invited to be a visiting scientist as part of an Arctic research program in the Kuskokwim Yukon Delta region. So Western Alaska, it's the home of the Yupik people, the homeland of the Yupik people. And in that region, permafrost is thawing. And as the permafrost thaws, the lakes are draining. Permafrost functions like the bedrock, and so the bedrock's not there, and the lakes are going away. And the program included 14 students, many of them students of color. And the aim was, it was a National Science Foundation funded program, and the aim was to support bringing these students into the earth system science, the environmental sciences, in recognition of it being one of the least diverse fields of science out there. Computer engineering has earth system science beat for diversity. So that was the aim of the program. And I recognized that this woman, as a Yupik person, she was the only person for whom it was her homeland, had insane insight, incredible insight beyond what we might associate with somebody who's 20 years old, 24 years old, because she had the insight of generations of her people who had been living in the region, and she brought that forward and shared herself with us. And one of the things, it hurt to hear someone say this. We were in a group of the scientist coordinating the program and myself, and somebody actually spoke and said the words, "I think everyone has potential as a scientist, except for," and they named her. And I was floored, because I just, in my mind, and what I saw, was the most exceptional person. Not that I want to judge and assess person to person, but I was learning more from her than from anyone else in the group, and stepping into spaces and walking the land. And one of the things she said about these lakes is, she said, we stood by the side of one of these draining lakes, and she said, when we lose the lakes, we lose the sky. And in something that simple, there is so much meaning. There's physics and chemistry. There's spirituality in a statement like that. There's a lot. And in the end, I'll shorten the story and just say that she and I left the program. And in my mind, it was not going to be a student leaving the program alone, that I would go with her. So it didn't happen in a pretty way, but we did end up on a helicopter and flighted out to Bethel. And then the next day was one of the most extraordinary days of my life, as she brought me even more into her world. And each part of the day, we spent meeting and talking to elders in her community. And I had a chance to step into 1,000, 2,000, 10,000 years of knowledge instead of the 14-day field program that we were doing and that space that we weren't listening in. So we are not alone in this work. And I don't think anyone who was running that program and made those statements, they are all good people with good intentions. We just don't always see what we're doing and what we're saying in the ways that it can impact that inclusive space. And it's wonderful to be here, to feel welcomed into this space, and to see where and how you all are working towards those kind of spaces here. So the last thing I'll highlight is that I've been spending a lot of time with psychologists. I've been spending a lot of time with psychologists because we know a lot about how our planet works, and we know a lot about what choices we need to make, and we're not making the choices for the long haul. So psychologists help us to understand that that's human behavior. And so I'd love to have conversations about where and how do we step in that space of bringing the psychologists, the behavioral psychologists, more into these spaces so we can help to understand ourselves better and learn simple practices. This is a practice that a Russian psychologist did with my class on Wednesday. She said, we should start with something as simple as, "Dear planet, thank you for." And when we do that and we express gratitude for our planet and for other people, we step into a space where we change inside us, and it's easier to connect with others in a way that we can cooperate more meaningfully and learn more from them. So I invite you all at some point in the day, I think I'm out of time now, but at some point in the day, take a moment, 2 moments, and think, "Dear planet, thank you for," and then find someone else who's done that and share your ideas with one another. So with that, we'll move on to the discussion.